Okay, guys, 6.1 is rational expressions and functions. We're going to specifically multiply and divide, and I'm going to add in here that we're going to simplify as well. Okay, and just understand that when I say rational, I mean fractions. Okay, we're talking about fractions, specifically fractions with polynomials in them. Okay, so that's what we're talking about in 6.1. So our objectives are, we're going to talk about rationals and what it means to be a rational. Okay, we're going to simplify, which is basically just reducing. Okay, you're going to hear, we're going to reduce, or a lot of times the word that you'll hear that we're going to cancel stuff. Okay, we're going to reduce them. We're going to multiply and simplify and divide and simplify to make our answers pretty. So first thing we're going to talk about is what is a rational expression. Okay. A rational expression, in the fancy mathy definition of it, is an expression that consists of a polynomial divided by a non-zero polynomial, because we can't divide by zero. Okay, that's called a rational expression. The following are examples of rational expressions. Okay, rational expressions, fractions. Okay, they can get as pretty or as ugly as you want, but we're going to treat them all the same. Okay, simplifying rational expressions and functions. As in arithmetic or in math, okay, rational expressions are simplified by removing a factor equal to 1. What I want you to understand is a factor equal to 1 means that you have the same thing on top, okay, and the same thing on bottom. And that's what I'm talking about when we cancel, okay, and we're going to get to that in a little bit. But if you have this polynomial, okay, one, it's in factored form. So the original of this, let me think, would be 2x squared minus 9x minus 5. Okay, you can't simplify until things are written as a product. Okay, and then this one is x squared minus 12x plus 35. Okay, you can't just start crossing stuff out until they're written as a product. Okay, and when you write them as a product, you'll notice that they have the same factors on top and bottom, which means you can cancel. That's how we simplify, and this is a better, prettier, more simplified answer. Okay, so not only are we simplifying, we're going to multiply. Products mean multiply. Okay, and when we multiply, we make it really complicated, but it's not that bad. Okay, to multiply two rational expressions, we multiply numerators and multiply denominators. So multiply tops and multiply bottoms. And the best advice I'm going to give you is this. Factor everything. Okay, factor everything. And then when we multiply, we just write our factors next to each other. Okay, so for example, okay, this, if you look at this, when I say factor everything, that means when we can. You look at this, nothing can be factored. So when we multiply, we have 2x plus 3 over y times 5 over 5, which is dumb because that's 1. But just so we are getting the idea of what's going on here, we are going, this equals, we're going to multiply the top. So it would be 5 times 2x plus 3 and 5 times y. Okay, I would prefer this is your answer, but sometimes they're going to want you to remultiply it out. So a better answer would be to distribute that 5. Okay, so it's 10x plus 15 over 5y. Okay, if they were simply asking you to multiply, normally they'll say multiply and simplify. So that's why I leave it in factored form so you can simplify. But that is the final answer for just multiplying. Okay. Here's the new example. It says simplify by removing a factor equal to 1. So you're trying to find something, a factor on top and on bottom that you can cancel out. So what I would suggest is writing down, knowing if you're good at your times tables, great. Okay, that's going to help you. But if I have 18x on top and 36y on bottom, okay, if you don't see right away that 18 times 2 is 36, that's fine. I would simplify it like this. I would say that 18 is 2 times 9, and then times x on top. And then bottom, 36 is 4 times 9. And then you could say, hold on, 4 is 2 times 2. So 2 times 2 times 9 times y. And then you can cancel. There's a 2 on top and a 2 on bottom, and a 9 on top and a 9 on bottom. So all I'm left with is an x on top and then a 2 and a y on bottom. Okay? As long as your times tables are right and you're not making up your own math, okay, you should be, no matter how you break up 18 and how you break up 36, if you're canceling all the common factors, you'll get to the same spot at the end. Okay? Big side note here, you're going to get asked this on some of the questions, but it says, because rational expressions often appear when we are writing functions, it is important that the function's domain not be changed as a result of simplifying. Meaning, if you're crossing stuff out, that doesn't change the domain of the original function. So the big thing you need to know is this, okay? The bottom can't be 0. That's how we find the domain. We start with everything, and then we take our bottom, okay, factor it, and then set the factors equal to 0. So I know that when x is 7, it makes my bottom 0, which is a big no-no. Okay, I also know that when my x is 5, it makes my bottom 0, which is a big no-no. So the way you would write that is you would say that your domain equals, and then they write it in set builder notation. They would say x such that x does not equal 7 and x does not equal 5. Meaning everything except for those two situations. And this is the big thing. Even though we can simplify this function and cancel this out, so this simplified would be 2x plus 1 over x minus 7, that doesn't mean that the x minus 5 doesn't count for domain. Okay? So just remember that. Okay? Or if it says restrictions or things like that, that all has to deal with your bottom, okay, the denominator. Okay, it says write the function given by this in simplest form and list all the restrictions on the domain. So if I'm going to simplify, I know that I need to factor everything. So I don't care how you factor, if you use box method or if you use grouping or whatever, okay, but we should be at the point where we know how to factor. If not, I'll refresh it really quickly. Okay, so I got to factor the top and factor the bottom. So if I'm going to factor the top, 3x squared plus 13x minus 10, okay, I'm going to do box method because that's what I teach all my little babies, okay? Box method tells me I need to put the first term here and the last term here. And then I need to find numbers that multiply to a times c, so negative 30, because that's 3 and negative 10, and adds to 13. And I make my little ones write out the list for 30. Okay, so it would be 1 and 30, 2 and 15, 3 and 10, and 5 and 6. And how I'm going to get 13 from that is not by 5 and 6, not by 1 and 30, but because it's negative 30, one of them needs to be negative. So it's not going to be this one. It's going to be 15 and negative 2. So I go 15x and negative 2x, and then I take out GCFs. So it's a 3x and a negative 2, and I get an x and a 5. So this top polynomial factors into 3x minus 2, x plus 5. Okay. Then we're going to do the next one. And we're going to do the same method, okay? Or I'll do the other method for the bottom. So 3x squared plus 19x minus 14. You would do 3 times negative 14, and you get negative 42. So you need to find numbers that add, multiply negative 42 and add to, and adds to 19. And those numbers are going to be 21 and negative 2. So I go 3x squared plus 21x minus 2x minus 14. This is just the other way if you've learned it. And then I group them. And I take out the 3x and I have x plus 7. And I take out the negative 2 and I have x plus 7. So it factors into 3x minus 2 and x plus 7. That's the bottom one. Okay? 3x minus 2 and x plus 7. Okay? The simplest form, I'm going to be able to cross these out. And so the simplest form would be x plus 5 over x plus 7. That would be my answer for simplest form. And then it says, and list all the restrictions, meaning I'm going to take each of these, okay, and set them equal to 0. So I would say 3x minus 2 equals 0. And solve for x, and I get x can't equal 2/3. I do the same thing with this plus 7, and I get x can't equal negative 7. So you could list your restrictions that way, or it might say domain is x such that x can't equal 2/3 and x can't equal negative 7, if that makes sense. Okay, I know that's a lot of work. The factoring was the hard part, but you have to factor in order to cancel. Okay, example 5. This one says to simplify, and sometimes you're going to have to get creative with this. The first thing you should notice is this top does not look right. That's not the right order. So I'm going to change this so it's negative t plus 5 over 5t minus 25. Okay, and the only way I can simplify and cancel is if I factor stuff out. So I'm going to factor this top, and if ever it starts with a fraction, not a fraction, if ever it starts with a negative, I'm going to take the negative out, and this becomes t minus 5. And then on bottom, it has a GCF of 5. And if I take out the 5, I get a t minus 5. Those cancel. So the simplified form would be negative 1 on top and 5 on bottom. Crushed it. Okay? Just a quick thing, I've kind of mentioned this before, but canceling is a shortcut often used for removing a factor equal to 1 when working with fractions. Canceling removes factors equal to 1 in products. Okay, this is what I've been talking about. You can only cancel when it's multiplication, not when it's addition and subtraction. That's why factoring is huge. Okay, so just remember that and don't make that rookie error. Okay, there's another thing. Don't do this. Don't just cancel things because you feel like it. Stop making up your own math. Okay, it has to be multiplication. Okay, this one says to multiply. I'm going to multiply, and that just means multiply straight across. So we kind of just combine them and write them as 1, but I'm going to combine like terms. Okay, couple of things. If it just asks you to multiply and doesn't simplify, you would just go straight from here and you go 5 times 8 is 40, and then you have an x and a y, and the bottom you say 4 times 9 is 36, and you'd have an x and a y. That might be one of your answers, but in Miss Bustle's personal opinion, that's a crappy answer, because why would you make something big and work with crazy big numbers when you could make it small? So what I would do right here is I would simplify. I would go, okay, let's cancel what I can. Because it's all product, this is 5 times x times 8 times y, 4 times y times 9 times x. You can cancel because they're all products. X's could cancel, y's could cancel, and then I'm going to look at my numbers. 5 isn't going to cancel with anything, but 8, I can rewrite that as 4 times 2, which means my 4's can cancel. And then on top, I have 5 times 2, which is 10. And on bottom, I have 9. and that is way better than that one. But just be careful. Look for both answers. If it doesn't say to simplify, it might want you to do this one. But in Miss Bustle's world, and Miss Bustle's always right, this one is way better. Okay? Way better. Okay. Multiply. I've walked through this one for you. I personally will never make you FOIL stuff back out. I would never make you FOIL stuff back out. I would rather you leave the answer like this. Okay? Just understand that you're going to put things and keep things together, put them in parentheses, and then when you multiply them, you're just writing them side by side. This one doesn't have anything that cancels, so I would leave it just like that. Okay? And number 8 says multiply, then simplify by removing a factor of 1. So, if I know I'm going to simplify, I'm going to factor these. Okay? And I'm not going to go through it. But this first one, the top stays the same. I'm going to put it in parentheses. And then my bottom, this is a difference of squares. So it's an a plus 5 and an a minus 5. Okay? And then when I multiply, I kind of just put them together. So I'm just going to make this line really long. And then this guy factors into a minus 5, a plus 1. And then this bottom one factors into, it needs to multiply to 6 and add to negative 5. So it's going to be a minus 2, a minus 3. Okay? Because it's all products, I can start canceling whatever the freak I want that's on top and on bottom. So the a minus 5s can go, and then the a minus 2s can go. So my answer is the a plus 1 on top. And then I have an a plus 5 and an a minus 3. This is a good answer. If you can't see this as one of your options or it's not turning out right, then you might have to refoil the bottom back out and get a squared plus 2a minus 15. I like this answer. That's the full expanded answer. Both are the same thing. Okay, then the only thing that you need to know, we've talked about simplifying and multiplying this whole time. The only thing you need to know about dividing, okay, is dividing is this whole idea of the reciprocal. And you learned this a long time ago when you were little, I think in elementary school. But the reciprocal, just remember that it's flipped, okay? So 2x over 5 minus x squared. When we have reciprocals of rationals, we're flipping them. And just remember that if there is no bottom, you make a bottom, okay, and you flip it. But here's the big kicker. When you're dividing rational expressions, you flip the second one and multiply. And then the problems are just like the 7 that we did before. Okay, so flip and multiply when we divide. So we're looking at this equation. Divide and if possible simplify. We're going to take this one, we're going to flip it, meaning make the bottom the top and the top the bottom, and then simplify, multiply and simplify. So if I'm going to simplify, I need to factor everything. So this top one's going to stay the same. Difference of squares makes this x plus 4, x minus 4, and I'm going to keep things together by putting parentheses around it. And then this top one factors into x plus 4, x minus 2. I don't know why it keeps glitching out. Whoa. Okay, and then this bottom one, this guy right here, factors into x minus 7, x plus 1. Okay, now that everything's factored and it's all written as a product, I get to go to town and start canceling everything. So the x plus 1s cancel, the x plus 4s cancel, and so my answer is x minus 2, and then on bottom it's x minus 4, x minus 7, which is a great answer, but an even better answer, well, not an even better answer, maybe the answer they're looking for would be keep the top and then expand the bottom to x squared minus 11x plus 28. Both equally great answers. Things are awesome. go crush this assignment and get it done. Okay?